So in this video, we'll continue to look at CSEC Advanced Participle Question Solutions, and we'll be looking at a question from May-June 2019. This is question 7, which deals with probability and statistics. All right, so let's begin by looking at this question. Now, the question says, the weights in kilogram of students in a grade 5 class are displayed in the following stem and leaf diagram. So here we have stem and leaf diagram where the stem, of course, is in the middle, as indicated by these numbers 2, 3, 4, and 5. And we have leaves on either side. So basically it's a two-sided. Um, yeah, we have the leaves on either side. And of course it shows the weights of the girls and the weights of the boys. And of course we're given a key, which for instance means that 8/2 means 28 kilograms for the boys, and 2/8 means 28 for the girls. So again, the 2 here represents the stem. The numbers in the middle represent the stem. And of course, it's not uncommon for data to be represented like this for comparison purposes. All right, so what is first part of the question they ask us to do? It says state the number of students in the class. So this should be relatively simple. All you have to do is basically count the number of items in the data set, inclusive of both boys and girls. So here we have 3. We have 1, 2, 3, 4, 5, 6, 7. We have 1, 2, 3, 4. So this gives us a total of 3 plus 7, 10, plus 4, 14 girls, right? Then over here now we have 2 boys there. 1, 2, 3, 4, 5, another 5 there. Then 1, 2, 3, 4, 5, 6, 7, another 7 boys there. Then another 1. So say 2 plus 5, that's 7, plus 7, 14, plus 1, 15 boys. So we have 15 boys. And of course, that gives a total of 15 plus 14 equals 29 students in the class. So in total, there are 29 students in the class, okay? But we may need the number of boys and we may need the number of girls. So we say the number of boys is equal to 15. The number of girls equals 14. And of course, the number of students in the class is 29. So the number of students in total equals 29. All right, good. Now, the next part of the question says, what are we supposed to do here? It says construct one box and whisker plot for the entire grade 5 class, inclusive of boys and girls. Now, what information do we need in order to construct a box and whisker plot? Let's go ahead and write down that information. We need the lowest value. In this case, we're talking about the lowest weight. We also need the highest value, right? The highest value. We also need the median. We also need the lower quartile. So we need the lower quartile, which is normally represented as Q1. So let me put this as LQ for lower quartile, which is represented as Q1. And of course, we need the upper quartile, UQ, represented as Q3. And of course, the median is often represented as Q2. So we need those things, need those values in order to construct the box and whisker plot. All right. Now, let's just write out all these scores in order. So of course we can actually determine the median. So let me try to write them out in order. So for the girls and boys, with the step beginning with the stem of 2, we have 28, we have 28 again, we have another 28, and we have two 29s. So 29, 29. So far we have 1, 2, 3, 4, 5. So 3 28s, 2 29s, and let's scratch off those, right? So scratch off that. Now let's move on to the next stem. For the girls, we have two 32s. So we're going to have 32, another 32 there. We have 133 on the girl side, 133. We also have a 33 on the boy side. We have a 35 on the girl side, and we have a 37 on the boy side. And we have 338 for the girls and 339s for the boys. So write down 38, 38, 38, followed by 339s. 39, 39, 39. And that now takes care of the second stem. 2, 2, 3, 5, that. So yes. So let's continue. For the next stem, the stem is 4. Then basically we have, right, and I'm running out of space to the right there, but I'll just jot them down here. Next stem, of course, we have 40. Put a few here. So we have 40. How many 40s do we have? We have 1 on the girls' side and 2 on the boys. So put another 40 there. All right? So we're taking care of the 40s. Then we have 2 41s on the girls' side. And of course, we have 1, 2, 3, 4 41s on the boys' side. So 1, 2, 3, 4. Right? And then next, we have a 42 on the girls' side and 45 on the boys' side. So that should take care of all the weights with a stem of 4 for both girls and boys. And then lastly, we have stem of 5. There are no girls with that particular weight, but there's one boy with a weight of 51, right? So let's count our scores to ensure that we did not miss any, right? Because that is a common mistake when it comes to these problems. Whenever I have to write out, a large number of data, it is not uncommon for you to actually make a mistake and miscount or omit one or more of the data set or members of the data set. So let's count them. So we have 1, 2, 3, 4, 5, 6, 7. Oh, let me just put the numbers there since I'm going to be needing it later. So I'll put the numbers. So now that they're in order, I'll just put the numbers. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Yes, so we have 29 weights. Good. So now that we've done that, let's now locate the median, right? Now, because this is an odd number of items, then the median will be easy to determine, right? So we basically count from either end until we get to the middle number. And of course, another way of doing it is to say that, for instance, we could say that 29 minus 1 divided by 2, which gives us 28 divided by 2 is equal to, well, 14. So basically, the median would be the 15th element. So this would be 14 plus 1, which of course gives us the 15th element. So basically, we count 14 items from either end, and when we do that, we leave the middle item, which of course is the 15th. So since we already numbered or labeled the items with their particular number, we should be able to recognize that the median, which is the 15th item, is 39, right? So we've done that. Good. So in this particular case, the median, which of course we can call Q2, is equal to 39, which of course is the 15th item. Now, how do we determine the lower quartile? The lower quartile, Q1. Now, the lower quartile is essentially the median of the lower half of the data set. Let me repeat that. The lower quartile is the median of the lower half of the data set. Now, how many items do we have in the lower half of the data set? We have an even number of items, 14. And so therefore, the median is going to be the average of the 2 in the middle. Now, if we have 14 items and we count from left and from right, we're going to count 6 from either end, and that leaves the 7th and the 8th item, which are, of course, in the middle, right? So 14 divided by 2 is 7. So we want 6 from either end. So once again, because we have 14, an even number of items, if we count 1, 2, 3, 4, 5, 6, from the left, then 1, 2, 3, 4, 5, 6 from the right, then that leaves the 7th and 8th item in the middle. And so the lower quartile is going to be equal to the average of the 7th and the 8th item, which of course is 32 plus 33 divided by 2, which gives us 32.5. And so the lower quartile is actually equal to 32.5. All right. Now let's go ahead and now find the upper quartile. The upper quartile which of course we term Q3, is going to be equal to the median of the upper half of the data set. So we're talking about items 16 to 29. And again, there are 14 of such items. And just as we did before, we count 6 from the lower end, 6 from the upper end, and that leaves the 7th and the 8th in the middle. So let's count and find those items. So this will of course be a 1, 2, 3, 4, 5, 6, 7, 8, well, I continue 9, 10, 11, 12, 13, 14, right? So just as expected, we have 14 items in the upper half of the data set. And of course, the upper quartile is going to be the average of the two in the middle, which of course are the 22nd and the 23rd item, right? So let me just check that to ensure that is correct. So the upper quartile is the average of the 22nd and the 23rd item, which of course happen to both be equal to 41. And so this is simply going to be equal to 41 plus 41 divided by 2, which of course gives us 41. And so the upper quartile is 41. So what have we found so far? We found the median Q2, which is 39 kilograms, the lower quartile Q1, which is 32.5 kilograms, the upper quartile Q3, which is 41 kilograms. And if you go back to our checklist, we need, so we can check off the upper quartile, lower quartile, median. The lowest and the highest values are easily determined. We simply look at the data set and identify the smallest and the largest. And of course, these correspond to 28 and 51 respectively, right? So now we can complete our checklist. We have the lowest value and the highest value. We have the upper quartile, the lower quartile, and of course, we have the median. Now, I'm going to be doing a rough sketch of the box and whisker plot, but you have to remember that when you're doing this on the exam, you have to draw it to scale. So you have to use scale drawing. So you take your ruler, for instance, and you draw a line of certain length, and you should choose a particular scale, and you should stick rigidly to that scale, right? So let me do a rough drawing of the box and whisker plot here. All right, so let that be the box component, right? Now, what goes on the box? On the box, we'll have to place the lower quartile, the upper quartile, and the median, right? So the lower quartile is 32.5. So therefore, this end right here would be at 32.5. That is the lower quartile. The upper quartile, 41, goes at the opposite end of the box. And because you're drawing to scale, we must always make sure that the position of the median is correct relative to the other quartiles. What exactly does that mean? If you notice, the median is 39, and of course the lower quartile is 32.5, but the upper quartile is 41. So naturally we can see that the median is quite closer to the upper quartile than it is to the lower quartile. But of course, as I mentioned before, you're supposed to be using scale drawing, right? Supposed to be using scale drawing, and that would allow you to represent it accurately. But because I'm doing a rough sketch, I will approximate it. I will approximate the median to be about here, right? Let's say median is about there. So that line inside the box and whisker plot represents the median, which of course is at 39. Are we finished? No, we're not finished. We must draw the whiskers, and the whiskers will extend from the lower end of the box, that is the lower quartile, to the lowest value, and then from the upper end of the box to the largest value. And of course, this must be reflective of the scales that we're using as well. So what is the lowest value? The lowest value is 28, while largest value is 51. Now let me just shift my box a little bit so I could get some more space to the right. Right, I just have to I shifted that too. Right, so let me just move this down. Right, let me just fix that. So this value here is lower quartile is 32.5, upper quartile is 41. This is a median, which of course is 39. All right, so that is our box. Now, in terms of the whiskers, as I mentioned before, the whiskers will extend from the lower quartile, the lower end of the box, to the lowest value, which of course is 28. And so that one whisker will run from this end here to 28. Now, as you can see, we see that 28 is not very far from 32.5. So let's say that is there. So that value will go down to about 28. So 28 will be right there. And the other whisker now let's pay attention to the other whisker. Now, the maximum value is 51. Now, we should be able to recognize that there's a larger gap between 41 and 51 than, say, between 28 and 32.5. And our box and whisker plot should reflect this, right? So when you draw the whisker, it should go a bit further than, than the previous one. Approximately about, 28, 32.5, that's about 4.5. From 41 to 51, that's 10. So roughly 2.5 times, right? So this whisker is supposed to be approximately, not exactly 2.5, but what is 4.5? That's about two and a third, yeah, about there. About two and a third times the length of the other one. So, and this value here, of course, would be 51, right? So this is basically a rough sketch of our box and whisker plot, but it is somewhat reflective of what we're supposed to represent. We have the lower quartile at 32.5, the upper quartile at 41, the median at 39, the lowest value of 28, and the largest value 51, right? Good. Now let's move on to the next part of the question. All right, so for the next part of the question, we'll have to do some heavy calculation here. The next part of the question wants us to find the standard deviation of the weights of the, oh no, not the boys, but they tell us that the standard deviation of the weight of the boys is 5.53 kilograms. And we're supposed to determine the standard deviation of the weight of the girls. And of course, then provide an interpretation of your answer for the girls compared to that given for the boys, right? So we would need all our values in order to determine the standard deviation. So I'm just going to, should I copy them from up here? Right, so let me copy them from here. Take out these. Take out these. Take out these. Take out that. Take out that. Take out that. So let's just copy and set up on this one. All right, so there we have all our data, right? Now, how do we calculate standard deviation? We have a couple formulas for standard deviation, and usually at the front of the booklet, there's also the formula for standard deviation is normally given. Now, in this particular question, the formula for the standard deviation is given as, well, S is equal to, well, the variance would be equal to sigma from I equals 1 to n of xi minus x bar squared over n. Now, that is a formula that was given at the front of the booklet. But in this particular case, what we're doing is we're finding the standard deviation or what is deemed to be a sample of the population. What exactly does that mean? In this particular question, the entire population is the population is the entire grade 5. But in this particular case, it just wants us to find the standard deviation of the girls' weight, which means that we're finding the standard deviation of the sample. So, all right, so I copy the entire data set here, but of course, I just remember that we're supposed to find the standard deviation of the girls' weight and not the boys. So I will have to discard this, all right, and go back and find the girls' weight. So this formula is given at the front of the booklet is normally used to find the standard deviation of the entire population. However, if you're using a sample of the population to find the standard deviation, the formula is modified to give this. Well, S squared is equal to sigma from I equals 1 to n of xi minus x bar squared all over n minus 1, right? Where n is the number of data points, right? So n minus 1. Now, it's going to give us slightly different value, but of course, it is significant enough to note the difference, all right? Now, let's go ahead and look at the values for the girls, all right? Let me just clear up some values on the screen here, and we can take off most of this. All right, so let's write down the girls' weights. The girls' weights are 28, 28, 29, 32, 32, 33, 35, 338s, and then we have 40, 241s, and then a 42. So it should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes. So that is the number of scores. So number of scores here for right? Now, in terms of the formula for calculating the standard deviation, of course I wrote on this one earlier. S squared, which is standard deviation or the variance rather of the sample, is equal to sigma from I equals 1 to n xi minus x bar squared all over n minus 1. Now, in previous past papers, the formula has also been given as this. S squared is equal to sigma x squared minus sigma x all squared over n, and the entire thing is then divided by n minus 1. And when you actually do the calculation with both formula, it actually works out to give the exact same thing. So both versions of the same formula, both versions of the formula will give the same value, exact same value for the variance, from which you can then find the standard deviation. So it all comes down to which one you're more comfortable with, and then you could basically stick to that one, right? Now, for the purpose of this question, I'm going to use, which one am I going to use? I'm going to use the first one. Should I use the first one? Yes, all right, let me use it. Let me use the first one. All right, let me use the first one. All right, so first of all, what this means is that we need to find the average. We need to find the mean, x bar. And so x bar is simply equal to the sum of all scores divided by the number of scores, right? So when we add up all of these numbers from 28 to 42, what do we get? Let's try to work that out. So we have 28, 28 plus 28 plus 29 plus 32 plus 32 plus 33 plus 35 plus 38, 338s. Then we have plus 40, then two 41s plus 42. And that gives us, I think, 495. This is 495. And we're dividing by the total number of scores. The girls, this is 14. And so 495 divided by 14, that gives us approximately 35.4. Right? So that is the mean. So 35.4. Now, to be honest, this formula is a little bit more tedious to use to calculate the variance and then the standard deviation. But since you started, let's just proceed. All right? So we have already calculated the mean. Now we're going to drop a little table which will facilitate our calculations. Where's my cursor? Where's my cursor? My cursor. Oh, our cursor is over there. All right, so we're going to drop a little table in which we will list our values. Now, sum of xi minus x bar squared, right? So we're going to drop a little table. Let's go ahead and drop. Let's see what's going to be in our table. We need to have x. Then, of course, we need to have x minus x bar. Then we need to have x minus x bar squared. And next, of course, need to have the sum of all of that, right? And we have about 14 sets of data. So let's just go ahead and make our lines a little bit better. So here's why. All right, how many do we have so far? Let me see, let me see, let me see. Let's draw. Let's see. All right, so let's put in our x values. Our x values, of course, 28, 28, 29, 32, 32. So we have 28, 28, 29, 32, 32, right? Then we have 33, 35, 38, 33, 35, 38. Then two more 38s. And then there's also 40, two 41s and a 42. So 40, 41, 41, then 42. right? So let's proceed. Now, before I go any further, let me just recheck the calculation of my mean. Because as we see from the formula, we're going to have to use the mean to calculate our standard deviation. And so if there's an error in the value, then of course it's going to throw us off. So let me just go back and recheck our mean, right? So 28 plus 28 plus 29 plus 232, which is 64, 64 plus 33 plus 35 plus 68 plus 338, that's basically 108, sorry, 104, yeah, 114 rather, plus 114, then plus 40 plus 82 plus 42. Right, so this is 495, and we'll divide that by 14. Right, so 35.4. So our mean is 35.4. Good. So having found the mean, now we can go ahead and calculate a standard deviation. Now, x minus x bar. Now, in some cases, you may see a subscript xi to represent that is the ith data set and so on, right? You may see that. And this, of course, is xi right here, and this is xi minus that. So we can go ahead and put in those values there now. All right, so let's do that. So what this means is that for each of these values, we're going to subtract the mean from it, and the mean is 35.4. So as you can see, some values are smaller than the mean, so they will give a negative value when we subtract them, and some are larger, we'll get a positive value. So this is said to be the deviation from the mean, right? So 28 minus 35.4, see that, 28 minus 35.4, that is minus 7.4. So this value right here is negative 7.4. This is also negative 7.4. 29 is 1 greater, so this is going to be negative 6.4. Then 32, and that's going to be negative 3.4. Negative 3.4 again. 33, that's negative 2.4. Sorry, 30, yeah, 33 and 32. Yeah, 33, negative 2.4. 35 is minus 0.4. 38, that would be no, that would be 2.6. Yes, 2.6. 38 again 2.6. 38 again 2.6. 40, that's going to be plus 2. 4.6. 41 plus 1. 5.6. And last few 5.6 again. And then 42 plus 1, 6.6, right? So those are our deviations. And then, of course, you must square these values. So we say now 7.4 squared, that gives us 54.76. So this is 54.76. This is also 54.76. 6.4 squared, 6.4 squared. That gives us 40.96. So 40.96. 3.4 squared. This gives us 11.56. So 11.56 twice. Then we have 2.4 squared, 5.76. And 0.4 squared, I know this one, this is 0.16. And 2.6 squared, 2.6 squared, that is 6.76. And we have three of that. So 6.76, 6.76, 6.76. Then we have 4.6 squared, 21.16, 21.16. Then 5.6 squared, that gives us 31.36. 31.36 again. Then we have 6.6 squared, that gives us 43.56. Right? So we managed to find all the squares of our deviations. And what we next need to do is to look at based on the formula, we need to add them all up and divide by n minus 1 in order to find the variance. So we're talking about using this version of the formula right here. This one we're using. Right? So we need to do that. So we can say sigma xi minus x bar squared equals, and we go to our calculator and we add up all those values in our third column. So let's start from the bottom. 43.56 plus 31.36 plus 31.36 plus 21.16 plus 6.76 plus 6.76 plus another 6.76. Then we have plus 0.16 plus 5.76 plus 11.56 plus another 11.56. All right, so this actually was written as 1. So we have to be very careful. Written as, let's be 11.56, right? So 5.76 plus 11.56 plus 11.56 again, plus 40 plus 40.96, right? 40.96. 40.96 plus 54.76 plus 54.76. Right, so this looks like 317.24. So sigma xi minus x bar squared is equal to 317.24. And we can therefore say that this over n minus 1 is going to be 317.24 divided by 14 minus 1, which is 317.24 divided by 13. So divided by 13, this gives us 24.40. I think I may have made a little mistake. The first time I did this calculation, I got about 25.1 something. So 24.40. So this probably has a little error somewhere, but the principle, of course, remains correct, right? The first time I did the question on the paper, I got sigma squared to be 25.1. So there may have been a little mistake somewhere, but again, the principle remains the same. And so this is 24.40. This is the s squared, which of course represents the variance. And so the standard deviation s is just the square root of the variance, square root of 24.40, and this gives us root answer approximately 4.94. So standard deviation of the girl's weight is 4.94. Now, what exactly does the standard deviation tell us? Standard deviation is what is called a measure of spread, or measure of, is a measure of dispersion or measure of spread, right? And however, the value by itself, I mean, does not really say a lot. However, when we compare it to the standard deviation of another data set, then we can actually tell which set of data has the greatest spread. Now, if you go back to the boys' values, we're told that the standard deviation of the weights is 5.53 kilograms. And what we've shown here is that the standard deviation for the girls is 4.94, which is slightly smaller. And what this therefore means is that, in terms of the interpretation, it means that there is a smaller spread among the girls' weights, which basically means that the girls' weights are more evenly distributed about the mean as opposed to the boys, due to the standard deviation of the girls' weights being slightly smaller than that of the boys. And this is basically how we interpret the information where the girls' standard deviation, or the standard deviation of the girls' weights, is slightly smaller than the standard deviation of the boys' weights. All right? Now, part 4 says determine the number of students above the 20th percentile for this class. Now, what exactly does this mean? What is a percentile? We should be able to identify or to relate percentile to percent. And of course, percent means out of 100. So when we speak about the percentile, 1 percentile is essentially dividing up the data like in 100 equal parts. And so the 20th percentile is what we're interested in. Now, there's a little formula which allows you to find the position of say, the kth or the kth percentile. And this formula is given as, we say, the position of the kth percentile is equal to k over 100 times n plus 1, where n is equal to the number of data points, right? In other words, number of items in the data set. So if we're interested in the position of the 20th percentile, we say L20 is equal to 20 over 100 times, now remember that in this data, there were 29 students in the class. So therefore, n equals 29, and therefore we have 29 plus 1, which is basically equal to 1/5 of 30, which is equal to 6. Now, what is the significance of this? What this is telling us is that the sixth um, data point corresponds to the 20th percentile. So the sixth data point corresponds to the 20th percentile. And of course, since we're interested in the total number of students, all right, so I actually, anyways, we're interested in the number of students above the 20th percentile. So if we were to look at the data set, oh, we'd have arranged them in order. I would have erased most of the ones I put in order, but we could still find it. So if we start at the center here, then of course this would be one, this would be one, two, three, say 4, 5, and the sixth would be this one right here. The sixth data point would be the first 32. So the first 32, and of course, if you count 6, then 6 from 29 leaves 23. And it therefore means that there would be 23 people above the 20th percentile. All right? So number of students above the 20th percentile of this class would be 23. That is the number of weights which are to the right of the 20th percentile item, which of course is the first 32. All right? Good. So that is the first part of this question. That one required quite a bit of calculation. In the end, but we got through. All right. So part B. A vendor has 15 apples on a tree, 5 red, 6 green, and 4 yellow. Customer requests 3 apples but does not specify a color. Determine the probability that the apples chosen contain one of each color. So that's part 1. So let's represent the situation. So basically we have 5 red. So we can say we have red, red. Well, let me use a color for that. So we have 5 red apples. So we have red, 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 red. We have 6 green apples. So green, 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 green. 6 green apples. And we have 4 yellow apples. So we have yellow, 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 yellow. How many apples in total? 5 plus 6, 11, plus 4, 15 apples in total. Now, they want us to get the, find the probability that the person having requested 3 apples will get one of each color. So we want to find the probability of getting, say, 3 apples. Well, I don't know how to word this, but anyways, probably of getting 3 apples, each of the same color, right? Each of a different color. One of each color. So probability of getting 3 apples, one of each color. Now, let's look at the number of ways that this can be done. Now, let's say, for instance, the apples are going to be picked individually. And let's look at the first pick, the second pick, and the third pick, right? And let's look at the number of possibilities. Now, let's say the first pick is a red apple. If the first pick is a red apple, then this means that the second can be yellow. And if the second is yellow, the third, of course, is green. That is one possibility. Let's look at the next possibility where the first is red. If the first is red, then these two can be interchanged. The second can be green, and the third can be yellow. So these are the two possibilities where the first apple chosen is red. Okay? And of course, remember the person is buying these apples, so they're selected without replacement. So it's like you're selecting a number of items without replacement, right? 3 items, 3 apples without replacement. So let's look at the case now where the first apple chosen is green. If the first apple chosen is green, then we can have a case where the second is yellow, and of course the third is red, right? Next possible option where the first is green, then those two can be interchanged. The second apple can be red, and the third apple, of course, can be yellow. Okay? The final possibility is where the first apple is yellow, and this means that the second can be red, and the third can be green, right? And the final possibility is where the second is yellow, sorry, the first is yellow, the second is green, and the third apple is red. Now, how many such possible combinations do we have? Let's count them. So basically I have 1, 2, 3, 4, 5, 6. So we have 6 such possible combinations. Now let's calculate the probabilities of each of these, right? So we'll work them out individually. So we're going to let the first one, we're going to say the probability of red on the first, or just I don't need to put the subscript. So the probability of just to put the combination, the probability of red RYG. So RYG. Now you have to remember that the apples are chosen without replacement. And so therefore, after the first apple is chosen, the probability of getting the second will be affected. And after the second apple is chosen, the probability of getting the third will also be affected. So let's do this. Now, how many red apples are there in total? There are 1, 2, 3, 4, 5 red apples to begin with. And there are 15 apples in total. So the first part here is going to be 5 over 15. Now, after the first apple, red apple is chosen, then the second is yellow, then that leaves 4 yellow apples from a total of 14 apples, okay? Because obviously the red one has not been replaced. After the first 2 apples have been chosen, red and yellow respectively, there are 1, 2, 3, 4, 5, 6 green apples out of a total of 13. So when we combine these numbers, we can combine these numbers and simplify as much as we possibly can and see what that gives us. Now, 5 over 15, that gives us 1/3. 4 over 14, that gives us 2/7. We can do further simplification. We can say 3 into itself goes 1, 3 into 6 goes 2. And so this leaves us with 1 times 2 times 2, which is 4, over 7 times 13, 7 10 70, plus 21, that's 91. So the probability of the first combination is 91. Now let's go and look at the others, right? Now, for the next, the probability of the second possible combination, RGY. So RGY, again, first red, that's 5 over 15. Green on the second attempt, green of course would be 6 over 14. And then yellow on the third attempt would be, how much is yellow again? 4 over 13. This is 4 over 13. Now, if we examine these numbers carefully, we realize that we have the same numerators at the same numerators, 5, 6, and 4, same denominators, 15, 14, 13. So naturally, this is going to give us the same number. So this is 4 over 91. Let's examine the others and see if we get something similar. So this first combination, of course, the probability is 4 over 91. This is also 4 over 91, right? Let's check the others. For the next one, probability of green, yellow, red. So green, and most likely these are going to give the same numbers in. So green, yellow, red. How many green to begin with? 6 over 15. So 6 over 15. After the first green is chosen, there are still 4 yellow and 14 in total. And after those first 2 are chosen, there are still 5 red and now 13 in total. And once again, what do you recognize? Same numbers at the top, same denominators, same numerators. So this gives the same 4 over 91. So this should be sufficient to let us know that each of these probabilities is going to be equal to 4 over 91. 4 over 91. 4 over 91. 4 over 91. Right? 4 over 91. So basically, the probability of getting 3 apples of a different color is 4 over 91. I mean, for each possible combination. And because there are 6 of them, we can say that the probability of getting 3 apples, each of a different color, is equal to 6 times 4 over 91, which gives us 24 over 91. And of course, the same result would have been obtained if we just add the sixth fraction, the 6 4 over 91, because of course, these events are deemed to be what we call mutually exclusive. What exactly does this mean? If for the 3, you get a red, a yellow, and a green in that order, then you simply cannot get a red, a green, and a yellow. So they are all mutually exclusive. And so basically add the individual probabilities. Okay? So that is that part of the question there. Oh, and of course, oh, we're almost finished. There's another part of the question which says the probability of getting that all are of the same color, right? Let's go and look at that part. So we want to now work out the probability that all three apples are of the same color. This one should be a little bit less tedious than the first part. Now, what exactly does it mean getting three apples of the same color? It means that we can get all three being red, all three being green, or all three being yellow. And against those events are what we call mutually exclusive, meaning that if you get three green apples, obviously you can't get three red apples, and vice versa, and so on, right? So we say that the probability of getting all of the same color, so three apples of the same color, this would be equal to the probability of, say, red, 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 or we could say here plus probability of getting yellow, 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 plus the probability of getting green, green, green. Now let's work these out. If you get a red on the first attempt, the probability of getting that is 5 over 15. First apple is red, that means you have 4 red apples left from a total of 14. And if the second is also red, that means you have 3 red apples left from a total of 12, right? Because it was 5 red apples to begin with. That is correct. And a total of 15 apples. So what does this give us? Let's try to simplify. So 5 over 15, that simplifies to give 1/3. This 3 will cancel. Well, let's leave that one. Well, yeah, let's leave that one. Anyways, mm, well, let's say that one cancels that one there. No, let me not cancel that one. Anyways, it's gonna work out to be the same thing. But anyways, let me put back this 3. So this 3 will cancel. This is 3 into 3 goes 1, 3 into 12 goes 4. Then, of course, we can say 4 into itself goes 1, 4 into itself is that there. So what does this leave us with? Leaves it with 1 times 1 times 1 in the numerator, which is 1 over 3 times 14, which is 1 over 42. All right? So the probability of getting 3 red apples would be 1 over 42, right? So yes, so let me just check the math there. 5 over 15 times 4 over 4. Oh, all right, I made a mistake here. Where did I get 12 from? That should be 13. So let me fix this. Let me fix this. So let me go again. Let me go again. So red on the first attempt, this is going to be 5 over 15. Red on the second attempt is 4 over 14. And red on the third attempt is going to be 3 over 13. Yes, that is correct now. And so now we can say 5 into itself goes 1. 5 into 15 goes 3. 4 can go, well, 2 can go into 4, leaving 2, and the 14 leaves 7. And then this 3 into itself 1, this 3 into that 1. And so we're left with 2 times 1 in the numerator, which is 2, divided by 7 times 13, which is 2 over 91. So the probability of getting 3 red apples is equal to 7 over 91. Now let's look at the probability of getting the 3 yellow apples. So P of yellow, yellow, yellow. How many yellow apples to begin with? 4 yellow apples from a total of 15. So the first yellow apple is yellow. First apple is yellow. Then this is 4 over 15, the probability of getting it. If the first was yellow, then the probability of getting a yellow on the second attempt is 3 over 14. And if the second was also yellow, the probability of getting a yellow on the third attempt is going to be equal to 2 over 13. All right? And how can we simplify these? We can say that, for instance, 2 into itself goes 1, 2 into 14 goes 7. 3 into itself goes 1, 3 into 15 goes 5. Is there anything else we can simplify? Doesn't seem so. We have 4 times 1 in the numerator, which gives us 4. Then we have 5 times 7, which is 35. 35 times 13, that's 350, plus 105, that's 455. I hope my maths is working correctly, right? So let me go again. So we simplified. So we say 3 into itself goes 1, 3 into 15 goes 5. So 2 into itself 1, 2 into 14, 7. Left with 4 times 1, 4 in the numerator. 5 sevens are 35. 35 times 13, that's 35 times 10, which is 350, plus 3 times 35, 105. 350 plus 105, that gives us 455. 4 over 455, yes. Now, the next combination is where we have probability of all being green. So the probability of green, green, green. How many green apples are there to begin with? Was it 6? Yes, 6 green apples. So the probability of getting a green on the first attempt is 6 over 15. If that was successful, then the probability of getting green on the second attempt is 5 over 14, because if you take out one green without replacement, the number of green apples would have reduced by 1, and the total number of apples would also reduce by 1, right? Now, if those two attempts were successful and green apples were obtained, then the probability of getting a green apple on the third attempt would be equal to 4 over 13. And let's see how we can simplify this. We can say 5 into itself goes 1, 5 into 15 goes 3. Then we can also say that 2 into 4 goes 2, 2 into 14 goes 7. Is there anything else that we can simplify in this? Unfortunately, no. So when we work this out, we get numerator 6 times 2, that is 12, over 3 7 is 21. 21 times 13. So let me see, 21 times 13. So 10 times 13, that's 130 times 2, 260. 260 plus 13, this is 12 over 273. So 12 over 273. So the probability of getting 3 green apples is 12 over 273. Now, we're not finished. So we can say that the probability of getting all of the same color would be to add these 3 probabilities, because as I mentioned before, they are mutually exclusive. And so when we add them up, we're going to get 2 over 91. So this is equal to 2 over 91 plus 4 over 455 plus 12 over 273, right? And these are definitely not fractions I could just add in my head. We could actually put it as decimals too if you want, right? So we could do that, right? Yeah. So 2 over 91, let's put it as a decimal to about 2 decimal places. So let's work with 3 to begin with. 3 decimal places, 0.022 plus 4 over 455, about, oh, no. 4 divided by 455. That's, give me this times 10 to the minus 3. So this is 0.0088. Add an extra decimal place there. And then 12 over 273. 12 divided by 273. This is 0.044. So 0.044. And when you add those up, we get plus 0.0088 plus 0.022. Approximately 0.075. This is equal to 0.075. So therefore, the probability of getting 3 apples of the same color is equal to 0.075. All right? So this question required quite a bit of work, especially this part here, which required the standard deviation of the girls' weights. And I would have highlighted that the value I calculated on the paper was slightly different from the value I got here. When I calculated the value first, I got about 5.01 or 5.02, which I approximated to 5. But even though the values are slightly different, the interpretation, of course, will be the same, because the standard deviation for the girls' weights is still less than the standard deviation of the boys' weights, which therefore tells us that there is less of a spread among the girls' weights and that their weights are more centrally distributed about the mean. All right. So this is the end of this question. Question 7 from June 2019, CSEC AdMaths.